Hi guys, Frankie V here with another episode of Working with Power Tools, and we're going to be continuing our series on our Casa conversion from Urban Terror 4.2 under ITEC 3 technology to Urban Terror HD under Unreal 4 engine technology. And the purpose of this series, of course, is to put the information out there of what it actually takes to be able to do a conversion, which we covered probably about 99% of the stuff that you needed to know in the first two episodes. So then the third episode, we're going to be talking a little bit about collision. It's the most boring subject on the planet, but it's something that we're going to have to cover. So you're going to have to excuse me if this is going to sound a little bit kerfuffled or whatever. So anybody who's kind of wandering in here, this is our effort, of course, to give a bit of a boost, a nod to ensure that third-party members who are interested in making maps for our particular game, which they do generally for free, is welcomed into to do so for the 4.2 or the Unreal 4 version. Most are obviously waiting for the actual physics of part of the game to come out, and that's why we're doing the conversion to Casa in the first place. The reason we're doing it, we're going to know I'm kind of backing up, but you never know who comes in late, is that the purpose of converting Casa over is so I can pass it off to Barbie and he can do his physics, game physics and what have you, and to actually test and make sure that it's going to match up with the game physics matches up with the 4.2 version. As mentioned before, we want the two to be the same. The ideal would have been if we could have booted out ITEC 3, slide in Unreal 4, and just continued on. We would all be happy campers, and we wouldn't be doing this today. But Casa as a conversion is, well, let's say is rather important to that endeavor. And then we'll do some other various different types of conversions too as well. Some maps that we have at our disposal that are designed specifically for jump mapping. And hopefully by the time we get to the alpha stages, we have a really good competitive type of map. And we have a map that's for jumping, and we have a map for this and a map for that for particular needs, and not have to depend on sourcing through the shooter example. Now that's what we're using. This is not Urban Terror HD that we're looking at. This is the shooter example as applied by Epic. Now it works great for testing purposes, and some people may say, well, it's not Urban Terror HD, but of course let's use some common sense here. I mean, Radiant doesn't have any way of being able to test or make adjustments inside of GDK Radiant for maps that are designed specifically for jump maps for ITEC 3 4.2. So we have a little bit more flexibility, a little bit more benefit here, of course, of being able to do some of those rudimentary environment testing. Now, what do I know about Casa? We see in front of us. I know it's to scale. I know it that it's going to conform player-wise to what we have represented in 4.2. So it's going to get as close as we can get without more or less sticking with 4.2, so to speak. So anyways, sorry about the squeaky noise. Moving on, we're talking about collision, which is, as you can tell, is probably a subject I'm trying to avoid, because it is rather, there literally is so much that you can do as far as needs and as to the purpose of fundamentally preventing the player from falling through a building or outside the map. And there's a big difference between the types of collisions that you obviously have in Radiant, which are just basically brushes with a texture material onto it. The texture material says this is such and such a brush, so when it's compiled as such. Unreal 4 is different. It's still a kind of a brush, but it has parameters. So when we bring in, let's say, for example, we go to our volumes down here. We bring in the box a blocking volume. This is a Swiss Army knife of blocking volumes. This is basically a brush that says player can't run through that. So if we hit play, boom, we're blocked. We can't move forward, obviously. Now this, we can obviously, if we wanted to, we can use this brush to build blocking volumes throughout the entire space, which is probably what I'm going to, in some areas, probably going to end up doing, because the actual UCX type of collision, this is really a simple a simple map. It has simple geometry that really doesn't need to have anything fancy dancy. But there are some areas that are rather complex. Like, for example, this building back here is a little bit more complex than just being an average, just a block here. Just an area that needs to be blocked off. We have an alleyway here. We have an alleyway back here. And back here, and of course that continues around the corner. So this is a little bit more complex than just, something that's simple by design. That it'd be easier to just kind of maintain it. I'll take an attempt at this is what I really want to use because it's all contained within it. But at the same time, this can be generated for us in an application like 3ds Max, and I'll get to that in a moment. I'll just kind of finish off a lot of the ideas that are as to collision in Unreal 4, particularly to this type of geometry. Okay, this is editable just as any brush would be, so we can grab the back side here and we can collapse that down, and we can grab this here. We can grab, I don't think we can grab an edge. Can we grab an edge? Yeah, we can grab an edge. Here we go, we can grab an edge. So this comes in handy as far as utility purposes go. Now, a good example of that is Abby. In Abby, I've decided to put in some door frames, fancy designs and stuff like that. The only problem with door frames is the players tend to get hitched up into the corners, the wedging of the corners of how the frame fits into the door frame. So let's take a look at here, for example. This is the typical doorway that most players want to see, because they don't get hooked up into the corners when they're trying to say back strafe. They're running backwards and then they get hooked up into the corner for a second, and then of course they're toast. They don't like that kind of thing. And since Casa is a competitive map, that's something that needs to be avoided, of course, because any kind of hitching at all, period, is a good way to, let's say, destroy the reputation of this map. And certainly my reputation as somebody who's doing a fix-em-up, so to speak. So the availability of this type of collision work can come in handy in being able to wedge the player through the door if that turns out to be the case through the practical plane. So we can create a funnel, which is pretty simple, straightforward. We just grab that, grab this edge. Come on, give me. I need a new mouse. Who wants to buy me a new mouse? Oh, never mind. I'll grab it by Versi. So if I grab that, and I grab that, and I pull that there, and I grab this in here, and I'm going to kind of make it a little bit more of a slope to kind of exaggerate it. So we have this this cheese slice here. So if I hit play, and I'm running and gunning backwards, you can see how it kind of channels me through the opening. Let's try that again. So if I'm running backwards, then everything kind of it kind of channels us through these little lynching points that might show up onto the map. I don't know about things like this area in here. I'll probably want a little bit of a wedge so we can make sure that the players are flowing through. As far as collision goes, this here too as well. Or I can just sort of pull the collision mesh out from the wall a little bit more so it covers that area. But well, why bother? We have this little handy dandy Swiss Army knife of collision geometry here that allows us to be able to do that, and don't have to worry too much at this stage about anything that we apply as far as covering as much area as possible. The other collision that's worth I'll mention is, of course, this per surface, or let me go to the actual file, and we'll open that up. And instead of confumbling around, there's a couple of different types of collision that is per surface. So in this case, we're going to be using use complex collision as simple. There's also use simple collision as complex. Sometimes one will work better than the other, and usually if you apply it and one doesn't work, switch over to the other and it will work for you. What this does is it gives a per surface collision. If you're coming from Radiant, you probably recognized in Word spawn flag 6, which is probably the biggest way, worst way, that a thing that you could use, because it does basically take a face that a planar surface is made out of, such as this. There's no, a polygon is divided by faces, and once we import it into any kind of game engine, whatever was originally in polygons is converted to tris or faces. So a polygon is just made up of two faces with the dividing edge made invisible. So that's all it is. So this gives us per face collision. But unlike in Radiant, which takes that face and divides it up into a brush, giving you equal sides, top, bottom, and sides, as brushes are used for collision in Radiant, in id Tech 3. Per surface is just that. It means that there's no extra additional geometry that is required to support that type of collision, and of course that collision is in the direction of the face normal. So this is up in the side that you see the texture is the face normal. So this means how can we make use of it? In Radiant, flag 6, of course, is a good cheat to quickly be able to just kind of test a map out, and that's what we used at the beginning here. We applied a simple complex slash complex type of collision to our geometry, so we can just get in and make sure that all our materials are connected up, and we get good lighting, and things aren't. It doesn't. It's not an ugly map to start converting in the first place, and instead focus more on working a progression towards making the actual collision. But in this case, what we need to be is a little bit more smarter. So as I said before, the most important element as far as the world goes is the ground, because that's what the player runs onto. So in a worst case scenario, we'll just use this as per surface collision to make sure that the player doesn't fall through the map. That's that's the whole intention really behind collision. But on the other hand, how to use it appropriately, how to use collision appropriately, really just takes a little bit more common sense and a calculator. So if we look at a surface and we take a calculator and we say, okay, per surface, we're looking at 8 surfaces to encompass this whole in this whole section with a collision mesh or a UCX collision box would take 10 surfaces, then which is the better option? Obviously the per surface is, because it's less surfaces to have to deal with. So that's the way we look at it. Okay, we sort of covered that aspect of it. Okay, we got this humongous mess out here, which is another, well, not so much a different type of collision. This is just straight up geometry with that per surface collision applied to it, and this has been added into a blueprint. So anytime I use any kind of vertical type of collision, box collision works great for vertical elements like a building and so forth, because you got a lot more sides to deal with. But of course, this is the outer boundaries of the map, so we can cut down on the resource hit by just using a per surface, apply that to simple geometry, and then shovel that into a blueprint, which allows us to give us some form of surface control, that particularly being able to turn off its visibility in game. So when we drop in, it disappears, but we can't walk through the wall. So we have collision, and that decreases the amount of geometry or collision surfaces, obviously for the exterior part of our map, by at least half, and that is actually a significant amount of geometry that is running around along the outer edges. So that's once again a good use of per surface collision. The other option, of course, is we have this lumpy, bumpy type of road. Boy, it would be kind of a nightmare to go in there and have to create a collision surface, an uneven surface. So once again, that's a good option for that type of collision element to be applied to it. Now, we did everything in mass, in bulk, and to kind of demonstrate where everything is controlled from, you would think that, okay, we're bound to a particular content in our map, which is not the case. If we go onto the floor here, you can see that this is our binding element. This is the element that the collision is actually bound to. So if I select this collision, you can see over here, The first information is the folder it's found it under, and of course this is the actual name of the object, which is collision 99. So if I grab this and I start moving it up, I'll probably have to look around. Oh, there it is, way over there. You see the see the collision mesh starting to climb up. So we don't actually have to bind collision to a particular building, as in building 4 has collision mesh UCX building 4. Okay, so do I really want to get into that just yet? I don't think so. If I didn't mention it, as I say, this is this is a confusing subject. Don't worry about the mismatch mappings that was to be expected when we started breaking things off into separate boxes and what have you. Blocks of building information, and that'll be corrected. Everything will be corrected in the next version. Okay, so that brings us to what the purpose. Before I actually start talking about UCX collision. Okay, well, let's just kind of touch on it a little bit. UCX is the 20-pound sledgehammer in the box, because it's almost guaranteed that whatever you apply it to, it will work. Now, 10 times out of 10, if it doesn't work, it's because I made a mistake, and I have a misspelling, or I applied it wrong, or it's not connected properly, or it's there in the scene, but it's been malformed or what have you. And I'll get to that in just a minute. But the whole purpose of bringing the UCX collision mesh in is to once again test out playability of the map in real time to find problems. And here we have walking is a good way to find problems, because here's a problem. That's an issue. Here comes a problem. That's an issue. The physics dynamics of the player, particularly in shooter, I guess, is here's to real-world orientation. So steps like this, the player is going to want to try to walk up the steps. Going to want to try to walk down the steps. This is not good. If we run, if we want to run, it's not as bad, but it's not good either. So a decision to made, of course, is because Casa is a comp map, is to ramp the stairs as opposed to doing step stairs. So that's one of the benefits of doing this type of testing in bulk, and don't worry about as per item, line item. We tested for lighting. Okay, that worked out good. We tested for make sure that matrix our material matrix was actually working, and it was all connected to properly to the proper surfaces, so we have that one-to-one match. That's the only time it's really critical, because if we were doing it, if I was making this as my own map, then of course I would be bringing stuff in without materials to begin with. But we want that one-to-one match, so that's pretty important. So we've created that pathway. So now we've had the ability in mouse to test our collision out. Now I told you this is a dry subject. So anyways, that's why everything, if you look, as I pointed out, everything is connected to these planar objects down at the bottom here. Now, it might not look like it, but there's about 105 of those, which corresponds to the amount of collision geometry, actual collision geometry that we have present. Okay, so let's try to finish this off in at least some kind of logical manner by taking a jump over to 3ds Max to take a look at it and what I did for that purpose. Now, I want the collision, obviously, but I don't want to spend too much time sorting things out. So I built everything under a single folder, under a misspelled collision layer. Oops, stop that. That's I think I have to use the scroll bar in this case. And as you can see, on a collision folder, I have geometry that's marked as collision and then numbered. This is the same technique that we use by renaming all our volume blocks where our different buildings are located, and then just basically built the geometry channel that all into a single folder, and then rename everything based on its purpose and intent of use. So anything that's marked with UCX is a UCX collision volume. It covers a certain amount of space, and then, but to be able to make use of it, it has to be assigned to a piece of geometry. So in this case, I'm just simply using a face located at 0, 0, 0 that corresponds to whatever comes after the prefix. So a face will be, I need my glasses, I need my glasses. Okay, so we have collision, for example, 25, UCX collision 25, so there'll be a face plane in there somewhere that says collision 25. Basic 101 box editing. And I would suggest sticking with boxes because it's almost guaranteed to work. There's two types of box type collision. There's convex and concave, and both of them function slightly different. Has a slightly different prefix. I would recommend, and I'm not going to suggest use the other one, but stick with UCX and box modeling because that's exactly what it is. You just don't have to worry about it. Just works. In that case, what you would do is to create a primitive box, drag and drop it out there, and if we want to cover a zigzag type of environment, we can move that there, and if we want another section covered, we can drag that out there. Now normally what I do is I drop my bottom down to underneath the 0, 0, 0, and probably not too important, but you'll find out anyways somewhere down the road. Bring your level up about 20 to 30 units above ground, above 0, 0, 0, because you want to be able to snap your collision right down to the floor. That way you can make sure that you're capped off at the top, and that the bottom of the collision mesh always drives through the ground. So it's you're not sort of creating a hole in your geometry kind of thing. Now to make things simpler, well, sort of, I created a material that I use for assigning. This is 101 stuff again. This is a modeling texture, and I just select that and assign this material, so you can see that this material is set up as being collision. Name means nothing, but what it does, it allows you to do is, for example, assign this particular material to what would be a collision object, and then we can select by material type, and anything that's been assigned that material type can be selected quite easily. And then we can just do an export by selection, and out it goes. So what we have over here as part of our selection is 230 objects. So this contains the UCX geometry, as well as the supporting mesh geometry, which is located, as I pointed out in Unreal 4, as being will be located at 0, 0, 0 as part of that connection. So if we take this box, continue on with our little box examination of our box here, we'll convert this over to an editable poly. And this is probably all you. I'm not going to go too deep, as I said. I mean, we can do a whole bunch of build it type of how-to videos later on down the road. Okay, so we'll go attach, attach, attach. Okay, and then we'll move that over here, and that's UCX box 4. So if we go ahead, or that's box 004. So if this is our collision geometry encompassing all things that is Casa. That would be UCX. Ooh, this is not physics. UCX underscore box 004. Now that to make that work, we need a corresponding geometry. So what do we need? We need create standard primitive. Obviously, we'll leave that over there. Don't do too much messing around with it. And of course, that's box 004. Oh, okay. That's UCX box 004. Oh. It automatically generated the same name, which I wasn't really expecting that, but that will then work with this. See how that works? UCX underscore box 004 geometry box 004. So if we bring this in, what happens then is that Unreal 4 does its thing. Oops. Stop that. And it will generate a box volume just like this. Although we can't obviously edit it as easily. So did Okay, did I cover everything that I wanted to cover? I think so. Okay, so needless to say, collision is a pretty deep subject. Better off to ask questions isolated to individual requirements. I'll be getting into the next episode is, where'd you come from? Hello, goodbye. Okay, hold on. I'll be getting into the next episode is where things are going to get a little bit more interesting, where we're going to start assembling stuff, putting it together, and heading towards the completion of this conversion. To be honest, I could have been finished by now. But we're going to be dealing with subdividing stuff. I'm going to be dealing with going back to my preferred workflow later on, where I want to be able to put my collision and information and what have you into subdirectories. It's just for the purpose of the lecture, it's just easier to present everything in such a big chunk like this, rather than we're going to be running down through different types of folders and what have you. So next episode, I'm going to start having hopefully I'll have the FBX. I'll have the FBX pathway set up as far as file folders and structure, so we can have a place to start dumping all of these little bits and pieces and start making a little bit more, let's say, logical type of build choices, as well as structurally the same as in Unreal 4. And then we can start seeing that connection between the two of them, which, to tell you the truth, you should be able to have a good idea that this is how it's going to work. We're just going to be demonstrating what I've been saying, kind of thing. Okay, so guys, I'm going to finish this up. Sorry, this is like the most boringest tutorial slash commentary or whatever you want to call it on the planet, and hopefully I'll catch you on the next one if you're still awake.